Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Syamim. Uh, okay, today I would like to talk about what have I learned about PLC. Okay, for the first slide is about the introduction of PLC. Okay, um, I, I will start with what the history of PLC. Okay, it was designed in 1970. Uh, it replaces the mechanical relays and it is used for the automotive industry. Okay. For the basic function of PLC is to control the machine and process. Okay, the advantages of the PLC is it can increase the reliability, and it has a faster response time, and also the communication capabilities. Okay, the type of PLC is it has a fixed PLC and also modular PLC. Okay, um, okay, for the chapter 2 is about familiarization with PLC Omron CP series CP1E CPU unit. Okay, um, uh, what we have learned is we got to familiarize with the Omron CP series CP1E CPU unit. Okay, we do some experiment and also we need to submit the report, and then we also know that this PLC CP1E also similar with the PLC CP1E training kit. Okay. We also learn how to do the installation technique, and then also the PLC maintenance and also the troubleshooting method. Okay, for the next chapter about the PLC programming, we learn about the programming language and then the ladder diagram. We make the ladder diagram in the CX programmer software. We have to download the software first, and then we can do the ladder diagram in it. Okay, after that, we learn about the basic ladder logic instruction, and then also the control instruction bits, and the last one is about the counter and timer. Everything we learn, we must adapt it on the CX programmer to do the circuit. Okay, after that, we learn about the process sequence description. Um, talk about the simple narrative. We learn about how the graph set and sequential function chart, SFC, motion, displacement diagram, and also Boolean. Okay, this is on the right side of the slide. This is the example of a simple narrative question. And then for the second one is this is the motion diagram, the input and also the output, the start, and then go to the IR1 and then stop, and then the lamp will go off. Okay, for the last feature is about the graph set, how the device work from the start, and then it will go to the step 1, the lamp will turn on, and then it will stop, and then the lamp will turn off. Okay, for the last slide, the teaching and learning improvement the need to do is the lecturer need to connect to the student individually. If they have some problem, they can tell you what is the problem, what they did not understand in class. So, and then the second one is consider new learning method. instead of individual assignment, I think you need to give more group assignment so they can do the work, teamwork, do the work in team. So it's easier for them to understand what they have learned in the subject. So for the final one is provide collaboration, socialize opportunity. For this is we need to do a lot of online meeting, Google Meet in classes, and discuss what they did not understand and what they have learned, and then give some quizzes and tasks so they can increase their understanding about what did they have learned. Okay, that's all for me. Thank you.
CS Programmer is a programming tool that used for the creation, testing, and the maintenance for PLCs. It consists with Omron's PLCs such as a C, S, CJ series, CB series, and the C series. CX Programmer version X is sold as a figure above. Is based on the graphical user interface that may help user in creating simple program or even very complex program, but also used for the program monitoring, editing, uploading, and the downloading program. A network setting and the mode change with CS Programmer. Users can create a new program from the later diagram. Thus, this will give a greater understanding while in the debugging plus good debugging technical provided. This is a PLC workplace as shown as the figure of the project's workplace window shows the objects inside a CX Programmer objects as a hierarchical trees. It's possible to add multiple PLCs to a single project. Each PLC on the trees can have a foreign objects attached to it. This is I/O table. The PLC I/O table, which contains a map of racks and until to be attached to the PLC in order for the PLC program to work properly. There is PLC settings, the PLC setup, the memory card found device attached to the PLC, the error log, the PLC error logs. This is only available during online. Expression instruction, the PLC expression instruction table, and the memory, the PLC memory. Come to rungs. A later rungs is horizontal slice of the later programs which contain a complete signal side of the logic instruction which allow power to flow from the left power bar to the right power bar. Here come to the compiling. The CX Programmer provide an option for compiling the whole project or just compiling an individual program or the function blocks. When either of those options is selected, the program code will be program checked and then compiled down to the object code that can be downloaded to the PLC. If any error are found during the compilation, they will be displayed in the compile tab of the output window. Work online or offline. By default, CS Programmer task begins in the offline stage for any PLCs. In this stage, the PLC doesn't need to physically connect to the computers and not attempt is made to communicate with it. In the offline stage, you can write your own programmers and compile them, but do not transfer them to the PLC or the monitor tabs. You need to work online to interact with the PLC. That is work online stage. When the go online is selected, the CS programmer will automatically will get the information of the PLC type and network settings from the connected PLC. It goes online to connected PLCs and transfer the data from the PLC. If the CS programmer fails to get the information, an error message will be displayed. The program symptom tables, I/O table, PLC setting, and the commands in the PLC will be uploaded to the CS programmer automatically. Select the memory option from the view menu to display the memories represented of the ladder diagram. The memory editor behave in a similar way to a text editor, except that you can be in the blocks or editing mode. When starting the memory editor, it opens in the block mode and whole line is shown selected at the present position. In this mode, it is possible to manipulate the line of the memories using the copy, cut, paste, and delete option. This is fine. The file dialogs allows various types of search to be carried out inside a window or from the project's workplace. Online edit. It is possible to perform editing of the program which is resident and running in the PLCs. While online, a set of edits can be matched which are the directed to the PLC which the PLC is actually running. This is running. That is very dangerous. Cautions extremely care must be taken when performing these operations to avoid the unsafe machinery actions. Online edits and sends the change. This option sends the edited regions back to the PLC. A program check is first carried out to confirm that the edits are valid. From now we can create our own programs. We can simply use the instruction from the toolbars or from the shortcut. Wait, I have to delete all the programs from this. If the inputs we are using the normally context, then we can choose from the instruction toolbar or from the shortcut. Then put into the runs. That is run. After that, we have to give him address. Examples like this is 0.00. This is output, and we give him names. The edit comments like start button. After that, we give him output. This is 100.00. Motto. And we links them. After that, if we want to stop the programs, we want to stop the motto, we can just simply add a normally cross from the instructions from the instruction toolbars and simply place over there. We give him 0.01 address and stop button. Okay, that's all. We can stimulate from the stimulation there and clicks on the works online simulator. We have to read load of everything's the LD over there. Checks our IO tables from from the health and click on the I/O memory reference, and remember that we have choose the CP1E, and we just click that. This is the references for the CP1E. After that, we can check the instructions reference for the CP1E series. Just click from the health and instruction reference and do the CP1E series. This is the instruction list for the CP1E. Every test we finish drawing the programs, we have to check programs is this correct or any error occurs. We have to compile it first. We just click the compile PLC programs, and it shows compoundings and no error occurs. That means the program is correct and is functionable. After that, we can check the memory code. We just click from the view memory, and it shows the instructions over there. The step zeros, this is for the start buttons. The second step is the end nodes for the stop buttons. The last step for the motor. Okay, from now we try the making it error occurs. Let's see the programs how to respond to the user, to us, and we just simply add the new vehicle. Just for example, it is over there and over there, and we click on the stimulation. We click on the compounds and see. We can see that the arrow directs the display 2 arrows over there, so it means the program is wrong or any false occurs. That's all the SOP for creating the data diagrams by using the CX programmer. That's all. Come to the SOP for transferring the programming PLC to the hardware. First of all, we construct the program as soon as the figure here. There's a start button, stop buttons, and there's a motor. First of all, we have to compile it first. For ensure and not any occurs, we can see from the arrow directs, and this is the 0 arrow and 0 warnings. It means the programming is correct, no error files and no warnings. But it shows if I make it error. Example like this: if any error occur or from the error dialogs, it means the program is incorrect. So you have to fix that, trouble this. This is the example. And after that, you have to select the PLC and works online. It will display this, and you just simply click yes. After that, you can see the green lines on the data diagram shows the PLC is in online mode. From now, we want to transfer the programming PLC to the hardware. We just simply click on the PLC and transfer to the PLC. After that, they will show these comments will be affected the stage of connected PLCs on do you wish to continue it, and you just click yes, and after that it will show this, and you just click yes and click OK. After that the PLC must be in the run mode, so you click yes. After that it popped up, doesn't not automatically show up this, you just click the run mode. This is the after programming PLC transfer to the PLC. This is a switch and this is output. This represents the motor. The LD 0.001 is the switch over there. The LD not 0.001 is the switch 2. If we press if you on the LD 0.00, you can see that there's a green light, and it means is activate the motor. The output 100 is right out. It means the motor is running. And next, when the switch for the 0.01 is on, the LEDs is off, or because the stop buttons is interact, and cause the motor is stop running. Familiarizations with the control instructions. The questions is over there. This is the data programs for the questions ones, and we stimulate it. Yeah. When the stop button is on, the motor is activated. When the stop button is on, the motor is stop running. The programs will active the outputs when the stop button is on, and will deactivate the output if the stop button is on, even when the stop button is on also. Let's try it. Question 2, as shown as the figures, and this is the data diagram for the questions 2. After that, we see that the program's output will turn on when the start button is on, and will stay on when it's released. When the start button is released, the program outputs will turn off when the stop button is on, and we see the results. When the start button is on and the motor is active, when the start button is released, it's still running, or because the ratchings, due to the ratchings over there. And if the stop button is on, the motor is off, it stop running. And next, this is the question 3. The data diagrams for the question 3 is here. When the start button is on, the motor is riding, the motor is activated. When the stop button is on, the motor is deactive. We modify the data diagrams by using the set and reset. The data diagram for the question 4, when the start button is on and the IR and active the motor. If the start button is released, the motor is still running. But if the stop button is interact, the motor is stop running. We can see that the program's output will turn on when the start button is pressed, and will stay on when the start button is released, all because due to the latchings, and it makes the progress maintaining the conditions so that the motor is still running. The program's output will turn off when the stop button is pressed is interrupt. The diagram for the question 5. Modify the circuit by using the keep instructions. When the stop button is on, you can see that the motor is running. When the stop button is interrupted, the motor is stop running.
Assalamualaikum warahmatullahi wabarakatuh and good evening. My name is Mohamad Nazirul Aiman bin Mahdi, metric number DN180067, and today in this video I will share about my opinion in PLC Programming and Application Lab BND 32103, and in this video also I will share about the introduction to PLC, develop ladder diagram using CS programmer, and last I will share about improvement in teaching and learning due to PLC subject. Okay, we go to the introduction. So first, what is PLC? PLC is a programmable logic controller, or PLC is a ruggedized computer used for industrial automation. This controller can automate a specific process, machine function, or even an entire production line. So, how does a PLC work? So, this PLC work, the PLC receive information from connected sensor or output device, process the data, and trigger output based on pre-programmed parameters. Depending on the inputs and outputs, a PLC can monitor and record runtime data such as machine productivity for operating temperature, automatically start and stop processes, generate alarm if a machine malfunction, and more. Programmable Programmable logic controller are flexible and robust control solution adaptable to almost any application. So next we go to the develop ladder diagram using CS programmer. So how we can design the CS programmer or ladder diagram using CS programmer? First, we need to ensure the design ladder diagram are free from error. Second, CS programmer will read the ladder diagram from left to right and top to bottom. So the CS programmer will read the ladder diagram from left to right and top to bottom. So in between the CS programmer and the hardware, we also can connect the CS programmer and the hardware using PLC. So how to connect the hardware and CS programmer? So first, we must ensure the connection PLC to the PC. Second, make sure the input selector and output selector. Third, transfer the program. 4. Make sure the program are free from error. 5. Test the program and run mode. Okay, so we continue with the next slide. So in this slide, we can see several type of ladder diagram using CS programmer. First, in direct control. Direct control ladder diagram is directly we control the input and output, such as when we push the start button and the motor will rotate. if we push the stop button and the motor will uh, stop. Okay, so that is the direct control. In second, in indirect control. So in indirect control we have two, which is indirect control dominant on and indirect control dominant off. Difference between the indirect control and direct control is indirect control use the internal relay as the medium to generate and to trigger the input and output. So if we use the internal relay, so that the current will energize the internal relay to trigger the output. Okay, next is keep. Keep. Keep is the set of keep operator like a latching relay. So it used to replace the normal latching, which is normal latching just like set and reset. So in keep we have two input, which is set and reset, and the next one is sets and reset, which is rset. Set is turn the operand bit on when the execution condition is on and does not affect the status of the operand bit when the execution condition is off. The are set to turn off a bit that have been turned on with set. So for the R set turn the operand bit off when the execution condition is on and does not affect the status of the operand bit when the execution condition is off. Use set to turn on a bit that have been turned off with R set. So for the conclusion, the previous video shows that there are several type of uh, ladder diagram in CS programmer and especially in PLC programmer. So then this is the last part for me. Improvement in teaching and learning due to PLC subject. So in my opinion, how can we improve our teaching and learning due this subject? So first, can give more explanation video, and student can repeat to understand the topic. Second, make a industrial talk about the importance of PLC. So this can give more information and give more knowledge to the student to this subject. So that's all from me. Thank you.